So one of the standard ways of dividing up different forms of memory, one of the older sets of terms used to describe two distinct sort of forms of memory are declarative memory versus procedural memory. And declarative memory is memory for facts and events. For example, like if you had, dinner last night, what did you eat? And, where did you eat it? And, who was there with you? Who made it? If you can remember all those facts and events, you are, exhibiting declarative memory. You're declaring something is where that sort of comes from. Versus procedural memory. Procedural memory is more like the habits, right, of, William James. Basically the idea that you are demonstrating, some skill or engaging in some behavior, but without any kind of reference necessarily to when it was you learned it, to each of these specific steps that are involved. It's like riding a bicycle. You know how to do it. It's a procedural memory, is what they say. Another form of memory is what's called emotional memory. Like you can maybe be exposed to something, that has, significance to you emotionally, there's like a salience to it. And it provokes a very powerful felt sort of response, or just even any kind of felt response. There's some sort of emotional response to it. And we're going to see that these different forms of memory, declarative memory, procedural memory, emotional memory, they're actually dependent to some extent on different networks in the brain. Declarative memory is going to really involve some of these regions that are in the middle of the brain, the medial temporal lobe area of the brain. So in the temporal lobes, particularly there's a structure that extends from from the front towards the back of the temporal lobe, about 8 centimeters long. It's known as the hippocampus, which is named after a seahorse. It looks seahorse shaped, and after the hippocamp, seahorse kind of a creature from Greek mythology. And it's, the hippocampus and other regions of the medial temporal lobe are going to be very important for declarative memory. For procedural memory, for, knowing how to ride a bike, or to, the skilled, to play an instrument, all those sorts of things that you acquire, you are dependent largely actually on more subcortical networks in the brain. The basal ganglia, for example, play a pretty significant role in many procedural memories, as does the cerebellum, at the back of the brain. And for emotional memory, there are limbic structures that are really deeply involved in sort of rapid sort of behavioral emotional responses, bodily responses to stimuli that you have had previous experience to and are responding to because you've had those past experiences. So that's a form of memory. And the amygdala, which is an almond-shaped nucleus in deep in the temporal lobe, just anterior, just in front of the hippocampus, is very much involved in sort of mediating some of those responses. And what's fascinating about memory is that while we can subdivide into declarative or procedural or emotional, actually when you're remembering an event or an experience, you may be deploying all three of these, sort of subdivided forms. For example, if you, are riding a bicycle, you could remember, you could be exhibiting the procedural memory. You could be, actually riding the bike. But you could also be remembering, who taught you how to ride the bike. There could be a specific event or experience that you're recalling about, that bike. And you could also, maybe you fell off the bike or something at one point, or you got your first bike. So you could remember aspects that have an emotional, salience to you as well. So all of these networks are kind of, involved and engaged sort of simultaneously. And, the reason we know about these sort of subdivisions to some extent and their dependence and reliance on different areas of the brain is because people who have damage to specific regions can lose a specific aspect of memory, like specifically the declarative memory, or the procedural memory, or the ability to acquire new procedural memories, or the emotional salience in response to, and emotion can often enhance, declarative memories. If you damage the amygdala, for example, which is so important for emotional memory, you may not get the enhancement of declarative memories that come with, the engagement of these networks that are important, these regions that are important for emotional memory. So we'll talk more about this, but long-term memory is divided into all these various forms that often are, operating hopefully in all of us, with intact brains, and intact memory systems, sort of simultaneously to provide that rich memory, that James talked